Hey everyone, I think it's time to start working on the next iteration of the big power naturally aspirated 2GR. As a reminder, or if you're new here, this is what we got last time, 405 wheel horsepower. Now note, that is on ethanol. I'll overlay here, 387 is what I got on pump gas, but that's the last we're going to be mentioning of pump gas. For now, this is going to be strictly ethanol. That motor build was a pretty simple one. It was valve springs, cams, and an intake. And the engine otherwise was completely stock. I did install the high compression pistons from the 2GR-FE, the stock hybrid application for that motor. But otherwise, it was all stock components in there. I tried to make that build as low cost as possible, and it proved it out, right? It made 405 wheel horsepower naturally aspirated. This build, we're going to try a little harder. I feel, and this is really just an estimate right now, I feel that we're going to get to about 440 wheel horsepower. We can talk about exactly why in a bit, but first things first, one of the things I'm going to do is we're going to rev this thing to 9,000 RPM in order to get there. Previously, we were stopping at 8,000, and realistically, that 8,000 wasn't a good number. Since it had stock connecting rods, we should have stopped at 7,800. The motor will take the abuse a couple times. In fact, to 8,000, it'll probably take it for years, but eventually those stock connecting rods will snap. And we don't want that. So for this build, we've got some BC connecting rods, so we can go to 9,000 RPM. We've got some CP pistons. The pistons are about 13.8 compression ratio. These things will go in the block fairly easily, but today, this is what we've got. The stock valve springs, as you can see, they are a single spring, just a straight spring. Not a bad unit. I mean, we're revving this thing to 7,200 very safely on the racetrack and just fine. So we want to go to this dual valve spring. This guy's got a little more pressure, and more importantly, it's got a lot more travel before it binds because you're splitting it across two springs, and dual valve springs don't have as many harmonic issues. Just overall, it's a better idea. Of course, that causes a problem. Let me show you guys. And I'm sure you've noticed by now, but I made a big investment in the channel. We got a new camera. So we're actually recording in 4K right now and hopefully get you some much clearer images. But back to this. Let's go ahead and just pop one of these off so I can show you guys the problem. So we've got the stock valve spring. And if you look down in there, you can see the stock valve seat is essentially matched to the inner diameter of this. So if we were to put the dual spring in there, first of all, there's no seat for that inner spring, but more importantly, it comes up because the inner spring is just resting on that shoulder right there. Now, it does clear the valve stem seal, so we're good there, and it clears it by a healthy amount. There's no problem there. But we need to machine that shoulder down. So how are we going to do that? And that's where this, my new Haas, well, new, it's 21-year-old Haas, comes into play. This is very much the bottom of the professional market, but it's still a proper CNC mill. Now, unfortunately, the first problem we have is how do we hold a head on here? I've got two vices, but that doesn't matter because the valves on a head are often tilted, and actually on many heads they're tilted in two axes. Thankfully here with these Toyota heads that we want to support, the 2AR and the 2GR, they're only tilted in one direction, so we only need to come up with a way to mount the head tilted this way. We don't need to compensate for this way. I mean, we might need to shim up and down this way to get everything just right, but we don't need much movement this way, just some shimming. And that's what we're going to do today. So the plan is, it's going to look a little bit like this here. I apologize, I'm not going to be good with these animations, maybe someday, but for now, it's that. That's going to be made. I've got this 2-inch linear guide shafting. So this is guaranteed pretty much straight as far as any of us are concerned. And then the place where the head is going to bolt onto is going to be this. So we got a 1 3/4 inch, 19-inch by 10-inch block of aluminum. We've got some more material here to make the saddle clamps. And the first thing we're going to do is, in order to hold that picture that I showed you a second ago, we're still going to hold it in the vices. I'm going to spread the vices out because that 30-inch long piece, that straight bar, is wider than the 19 inches we have for the head. But we're going to need to turn these into clamps to hold onto that bar. So that's the plan for today. Let's make some chips fly. Now, one of the things with this machine, since it's a more cost-effective machine, is there's not any of the nice features that you would expect on a newer machine. The big one here is we have no auto tool height detection, so we have to do all that manually, and that's what you're seeing right now. So at this point, we've got our clamps. Need to do a little bit of deburring, and yeah, I could have put a 6th tool in there and done the deburring automatically, but I didn't. We just need to flip them now and get rid of this so that we've got a fixed length. And by the way, these are offset so that I can use them like this or like this, because clearance is at a bit of a premium, but the higher you are, the more you can tilt. It'll be more obvious when we're done here. So let's go ahead and get this set up for Op 2. Yep, it appears to have stopped at an adequate location, so send it. And here's our part. Now, in order to avoid that situation I just had, I would have needed to just machine this a little bit deeper on the previous operation, or measure the height a little bit more precisely. I wasn't as precise as I could have been. The reason I didn't machine it further is on my 3/4 inch end mill here, I'm running out of cutting depth. I just need I need some end mills that are taller for stuff like this. So either way, I mean, I'm just getting started with this, so I don't have all the tools yet that I need. But she still works pretty good. Now, quick trip to the belt sander to clean up the edges. And well, I'm not going to sit here and say the surface finish is perfect, but it's good enough. And there's a part back there that you'll eventually see that has much better surface finish. The machine is capable of really good surface finish. It's just not, I'm just not being careful enough right now. But the way this works, we can see here in a second. So this is the way it's going to work. Obviously the blocks can be flipped to bring this up a little bit, but essentially there is nothing you're going to be able to do to rotate this bar at this point. So what we need now are the clamps that are going to go underneath and actually hold the bar and the plate that you don't see yet together. So let's get those made. Editor Mark here speaking. I I think I want to keep the machining to a minimum on this channel. I think having this machine is going to allow me to make a lot of really nice things, and those nice things might be things that I show on the channel, the results of them. The truth is there's a whole bunch of really good machining channels on YouTube, and I don't think my complete lack of experience really brings anything new to the table. I would love to hear from you guys in the comments, what you guys have to say about it, what you want to see. At the end of the day, you guys are the ones that kind of pick the direction for this channel, so I'd love your feedback. But for now, let's get back to the video. And now that we've converted most of this to scrap, we have our 4 saddle clamps. We need to make another setup to hold these, but hold them individually so we can get the bottom part of this off. And first thing I'm going to do is just trim these off on the bandsaw. This here is fast forwarded, but you can see just how much of the stuff is just not automated on this mill. But hey, I'm not complaining. I still have a CNC mill, and this is pretty awesome. So I'll push buttons for 10 minutes. Yeah, and here we go. We've got our holes for our socket head cap screws put in. Just got to repeat it 3 more times now. And now for the final part. This is the base plate. We've got a couple threaded holes to put in here, though not for the head yet. That's when we flip it, because this is the bottom side of it. We got to carve a groove here for the rod, and then make the threaded holes for the saddle clamps. And then, in order to indicate it on the other side, we're also going to clean up the 2 sides, but we can't clean up the front and back because, well, there's a vise in the way. So let's get to it. Here I'm having to babysit it a little bit. I really need to get a coolant situation going on here. It just, these deep holes without coolant are just not a great idea. Well, this is certainly a fun reminder to order spiral taps before these projects start. But now that the upper arm workout is done, I now have all the parts. Now, I do have, some regrets. When I was programming it, I made sure to put finishing passes on all the surfaces that mattered, and I didn't on the other side. And frankly, this is not going to affect anything, but it could have looked so much nicer for just a few more minutes worth of work. So I'm still getting used to this machine. Live and learn. It's still going to work just fine as a tool, and frankly, it's going to be underneath. Nobody but me will ever see it. But at this point, there is more work we have to do on the top surface. We have to get these sides in a way that they can be indicated in. But I don't have the, conveniently, I don't have the spiral tap that I'm going to need for the other side in order to mount the head. And I think I'm going to wait for that after that little arm workout, especially since it's only going to be a few days since until it's here. But let me just take a minute, put this together, and at least show you what the assembly looks like and what the intention is. All right, and there it is. The idea is there'll be holes in here to be able to mount a head, and then that can get tilted in any position in order to get some work done. Now, the travel, the Y travel is a little short on this machine. It's only 12 inches. So I might have to shim some blocks behind here to get the whole thing further this way. As it is, it does just barely reach the back, but it does reach further up front. So I don't know, it'll depend on the head. There might be some things I need to do. And then the other, and I knew this going in, but the other issue is this currently only tilts 60 degrees. So I will need to make some jaws. The first time I'm going to want to machine the side, I'm going to have to make some jaws that are kind of like these ones that I made on the back, but essentially like this, so they hold higher and while still being bolted on, because I can't just space it up much, because once it's past the middle of this, then the blocks would just eject. But as it is, this has got some nice smooth motion, and of course, you know, once you lock it down, oh, this is a mock-up. I don't even have the vices locked down. There is not going to be any moving that. And of course, I'll lock both sides. And then we can take a head, bolt it on, and do the machine work that we need to do. It'd be pretty rude to do all that work and not show you guys machining in action. I've got a head here that is scrap, so I went ahead and I grabbed some can't twist clamps. I put 3 of them on there, and it's nice and solid. I think honestly the biggest risk here is going to be machining a GoPro. I don't think it's going to happen though, but let's see what kind of shot you guys get. Well, that looks the part. Let's get it on the bench. All right, well, that looks the part. Let's put our spring seat in. Oh, this should fit. Okay, maybe a little snug on the ID. Obviously, I can adjust the program on that. We'll put our spring, that now. Oh. We gotta put a valve on first. Hold on. All right. Now we put our spring on. And a retainer and our keepers. And there we go. Now, I think, yeah, if I push down real hard, I can get it to move just a little bit. So obviously there's not enough spring pressure there. But that's what I need to measure, and that's why I've got all of these shims here so I can adjust it in. Obviously, this is not the solution for the final one, but that's the solution just to test, make sure that I've got this set up properly. And then it'll just be a question of making a proper thickness shim there. So yeah, I'm super happy with it. And something I didn't show earlier on this thing is just how well these springs that I found actually work. So you can see the inner spring here is sticking out. There's a shoulder on the factory retainer that is the perfect size. It's got just a little bit of slop, which you want, and it's 3 millimeters tall on that shoulder, so it helps guide everything nicely in place. And then this spring here is actually, it's actually about 2 millimeters shorter, though the small spring has more travel available to it than the large spring. So it's just gonna bring about 3 pounds of preload more than the other one based on the height. So I'm pretty stoked with that. This proves out the concept, and now I have the tool to do the actual 2GR heads. So Next video on this, we probably will be machining the actual 2GR heads. That may not be the next video that I release though, but it should be coming before too long. Oh, and thanks everyone. The amount of you guys that subscribed really kind of blew up the YouTube algorithm on the previous video. And we now have 1,000 new subscribers, and I've never had a video do so well as the last video, so thank you. Thank you. I really appreciate it. We'll see you guys in the next one. Bye.